start Unit 5, Graphing Functions. We're going to do this in a couple different parts. So part 1, we're going to do absolute value. So the first thing I want you guys to notice is, and once we do a couple problems, you'll see, but all absolute value, which is a V, makes a V. So they might shift left, right, up, down, and they might reflect, which would be an upside down V. But the point, the one thing that makes an absolute value what it is that it's always going to be a straight line, no curves, okay? And rather than being a straight line, it's always going to make a V shape, okay? So first, before we get started, we should probably talk about what an absolute value actually is. Or, I'm not going to tell you what absolute value is. We're going to refresh our memories because you should have at some point already learned what an absolute value is. Let me try to get closer to this. Okay, so the first thing to remember is that whenever we evaluate, really let's just talk about the word evaluate, we're trying to solve, right? So when we are evaluating an absolute value, it's important to remember that an absolute value is always going to be positive. So if we are doing the absolute value of -6, our answer would just be 6. If we have something actually inside of our absolute value, what we do is we keep the absolute value, we evaluate what's inside, okay, so 6 minus 10 is -4, and then we take the absolute value. So that's going to be +4. Okay. So when we have a function, this works the exact same way. So it wants us to do the function at -10 for 3 to the -10, which is the absolute value, and then -4. So this works just like order of operations. And when I told you, so our normal order of operations is P, E, M, D, left to right, A, S, left to right. Okay? But this P right here can be any grouping. Okay, whether it's parentheses, so we can have parentheses, we can have brackets, or absolute value. Okay, these are all different types of parentheses, and we always do these first. Grouping, sorry, not parentheses. Okay, so I'm going to multiply 3 times -10, so I get -30. And then before I do the subtraction, I'm actually going to take the absolute value. So I get 30 minus 4, which equals 26. Okay, so this is very important that you understand how we evaluate these questions in order to see how we get our graphs. So you guys should be thinking, well, what is an absolute value? Well, an absolute value, if you think back, is just the distance of a number from 0. Okay, so if you think of -6 and 6, okay, those are both the same distance away from 0, so they're both going to have the same absolute value. Alright, so now you're definitely going to want to have your calculator out. Okay, so the first thing I want to show you in the calculator is how to put this in. Okay, so hit your y equals, clear whatever in there. Okay, then what you're going to do is you're going to hit your math button. Okay, so your math button is right there, right here. Okay, so you're going to hit your math button. Oh, it's so bright. Sorry. Please scoosh this. Alright, you're going to hit your math button. So again, you're in y equals. You're going to hit your math button. You're going to scroll over to number, and then see it says ABS. That stands for absolute value. So you're going to press enter. Okay? So now this we only do when we are putting an absolute value in. We're just doing the absolute value of x. So whatever is inside of your absolute value goes inside of these parentheses. If it's x minus 1, put x minus 1. Now, if there was something on the outside, that's when you end the parenthesis and then you put the rest after. Okay? If you have a number before it, you put that, then you hit the number button, math button, and then number. Okay? So again, that was just, we hit the math button, go over to number, and there's where your absolute value is. Okay? Press graph. You see the shape. You go to your table, and here's our table. Okay? So what I want to do is I want to show you why that is what it is. So you should be able to fill out your table without drawing or without graphing it. So what we're going to do is, I have my table right here. Okay, so I want to have a good amount of data points. So I started at -3, then I ended at +3. Now what you notice, the absolute value of -3 and the absolute value of 3 is the same. Okay, so again, this is just the absolute value. I'm just showing you the actual work right here. All right, and then after that, you plot all your points. Okay, so this is what my absolute value looks like. All right, so now the next point, so what are some observations about the graph? So again, what I want to show you, what I explained already, is that this is going to make a V shape. It's symmetrical, right? So at -3 and +3, it's 3. At -2 and +2, it's 2. 1, 1, 1, 0, obviously. So you can, from that, okay, so -4 and +4 are both going to be the same. Okay, so again, this is symmetrical. So that would be our conjecture, our observation, not a conjecture. Okay, and then the next thing we're going to talk about is the range. Okay, so the range is always referring to the y values. Okay, always referring to the y values. So all y values. So I didn't give you a domain, right? This goes on forever. We have our arrows right here. So what this is saying, okay, is that it cannot go any lower than 0, right? And then it can be anything greater than 0. So this right here, our range, this represents infinity. Okay? That's why, so you can't reach infinity, so that's why we have just that less than sign. This is always going to be the same. You're always going to put your smallest number first, okay? And we'll do a bunch of these examples so you understand the range. So again, this is just saying that we can't have anything below the x-axis, so that is y cannot be less than 0. So now we're going to do we're going to negate our absolute value, okay? If you think back to when we did this in our last unit, you should kind of be thinking what could happen, okay? So just to show you, so I'm going to hit my negative sign. Okay, make sure you hit your negative, not your minus. Again, math, number, absolute value. Okay, we're just doing x. Okay, so notice our graph reflects over the x-axis. Look at our table. We get the same exact thing, but because the negative is on the outside of the absolute value, our answers can be negative. Normally that's not true, but because of the fact that the negative is on the outside, that can happen. Okay? So again, make sure, I'm just going to draw these in. Make sure that you guys are drawing these points, okay? Please make sure that you are drawing those points. That is what I'm looking for. Again, the minus sign is on the outside of the absolute value, so you take the absolute value and then you throw a negative sign in front. Okay, so for this one, the range if you notice, that's a little bit different, right? Because it can't be anything greater than 0. So this means that it goes from negative infinity all the way to 0. So negative infinity, all right, is just in the negative direction, okay? So if you want to write that down, that's an arrow. Okay, so that is negative infinity. And again, this is just all y values. So because the graph can't go anywhere up here, it can only go down here, right? Okay, now the domain would be all real numbers. You could pick any single number on the x-axis, and that would be your answer. Okay, so again, the range cannot go past, there is no possible number that x could be to give us anything greater than 0. Impossible, okay, because there's that negative in front. All right, and again, this is, remember, transformed. We're looking for shifting or reflecting, and this reflects over the x-axis. All right, the next one we're going to do, we're going to talk a little bit about notation again, all right, just to remember. So this is saying that you take the f of x and you're going to add 2 to it. So what you're putting in your calculator is actually x plus 2, okay? So right here, and this is a nice little thing to reflect back on, okay? So you're going to, again, put this in your calculator. I guess I should erase that first. Or I'll just only do it right here. There we go. Okay, so just do what it says. So it wants us to hit the math button, go over the number, and then hit absolute value, just like we did before. Throw your x in there, end your parenthesis, and then add your 2. Okay, so we have our table right here. Again, notice, so you don't want to start too high. So I usually start at -2 or -3. All right, and notice what happens to, so first I notice, okay, 0, 2, that's when it starts to fold, right? So what you're looking for that central point where it turns around, so your turnaround point, okay? And we'll use our vocabulary a little later. Okay? So if you put that on your graph, that's what you should get. Okay? So my original graph is right here. And then what happens with my g of x is it just shifts up 2, which makes sense because we added 2 to our function. Okay? So the range now is going to be a little bit different. Okay? Because now it can't go past this point. Okay? So while our domain for just the f of x, it can't go below 0, now this can't go below 2. All right? So our range is from 2 to infinity, or y is greater than 2. Okay? Another thing I want to talk about is notation. Okay? So another way I could write this would be 2, comma, infinity, and this would get a parenthesis. Okay? So if I have this, or, not the same thing. That would be the same thing as brackets. If I have greater than, or less than, or greater than, this is going to be parentheses. And we'll talk a little bit more about this, okay? And then again, it went up 2 units. So now that was if we added or subtracted, because it would just go down, to the outside of the parenthesis. Now if you get something that looks like this, this would be equal to x plus 2 inside of your absolute value. So we want to see how that moves. Okay. So if we did that, we would do, again, math, number, absolute value. So the x plus 2 is actually going to go all inside of the parentheses. If you have a different one, it actually will show you the absolute value, so that'll be even easier. Okay, go to the graph. Okay, and again, you kind of have to use your judgment. I noticed that -2, 0 is where it turns around. Okay, so you're trying to look for that point where it makes the turnaround. All right, so we're starting, we go 3, 2, 1, we're getting lower, then we go to 0, then we wrap back around. Okay, so that's how you choose which points to graph. Okay, so again, that is what our graph would look like. Those are the points we pick. And we always want to find that turnaround point. Okay, so that would be right here. Again, please put your dots, put your points on the graph. Okay, so then you're going to notice, again, your...
Please excuse the interruption. Until further notice, that
Okay, so actually nothing happens to the range. Okay, so stays the same as y equals. So those are going to be the same because it's just moving left and right. And then our domain, we want to know, when is it increasing? So when is it getting bigger? And to figure that out, let's look back at the graph. Okay, you see that, let's see. So when x is, and that's a little typo, when x is -2, so anything greater than -2, I'm going to change that in your notes. Okay, so when x is greater than or equal to -2, that's when it's increasing. Okay, so notice that it's going up. It's going up. Okay, so when x is greater than or equal to -2, that is when it will be increasing. All right, so now we're going to make some conjectures. Okay, so for, let's see. What you can do is you can try these in your graph, or try graphing these. Try graphing. All right. Okay, well, I'm going to let you know, okay, so this would go down 2 units, and -2 would actually go right 2 units. Okay, so a conjecture is basically just a guess or a prediction. This is definitely an important word. All right, great vocab word for the regent. All right, and we'll finish this off with going through a couple different translations. Okay, so if we add, so C is a constant, okay, so number. All right, so if we add C to the whole absolute value, this is going to be translated up however many units you're adding. If we subtract C, this will be translated down. Now if we do this within our absolute value, this is going to move, so if we did plus C, think about the example that we did. This moved it to the left. And if we subtract C, this moves it to the right. I know that sounds kind of backwards, but if you try it out, that is true. And for your homework, just this one problem. You can use example number 4. Be careful that you are putting this into your calculator correctly. You can see right here what I want. Remember, you can pick your points based on where the turnaround is. Okay, and then you're going to do the range, and you're going to say the range and when it is increasing.